So we've been given one piece of information. The value of cosine is negative 5/13. The second piece of information I guess we've been given is that theta is in the second quadrant. So based on that, we need to find the value of cos 2 theta, sine 2 theta, and tan 2 theta. Well, for number 1, we know that cos 2 theta is the same as cos 2a. Let's just try that again. So this would be cos squared theta minus sine squared theta. We do know cos theta, we don't know sine theta. However, we do have enough information to find it. We always can go back to our 8 fundamental trig identities. The biggest one that's going to be useful to us in the future is that sine squared plus cos squared equals 1. We don't know sine theta. We do know cos theta. Square negative 5 over 13, we get 25 over 169. And knowing that I'm going to have to take the 25 over 169 to the right side, I'm going to convert the 1 into 169 over 169 right away. Subtract the 25 over 169. Square root, plus or minus, obviously. The good news is we can square root both of these numbers exactly, so we get plus or minus 12 over 13. Whether or not this is actually plus or actually minus, we'll go back. Our angle is in quadrant 2. And if we go back to cast, which tells us in which quadrant which trig function is positive, quadrant 2 is S, meaning that sine is positive, so we'll actually be looking at positive 12 over 13. Now we have enough information to figure out the value of cos 2 theta. So cos squared theta is negative 5 over 13. We'll square that. Sine squared theta, sine theta we just found, 12 over 13. Negative 5 over 13 squared is 25 over 169. 12 over 13 squared, 144 over 169. Subtract those, and we get negative 119 over 169. Have to flip to the next page to do sine 2 theta. Formula for sine 2 theta is 2 sine theta cos theta. We don't need to find anything before we can use this. We already found sine theta in the last example. We can recycle it and use the 12 over 13 again. Cos theta still negative 5 over 13. Keeping in mind that for this multiplying, 2 is 2 over 1. Multiply that out, we get negative 120 over 169. Last one, to find tangent of 2 theta, we're not actually going to use a double angle identity, Because to do that, we would have to find tangent theta, which all we know is sine and cosine. We can say that tangent equals sine over cosine. Find tangent theta, plug it in and find tangent 2 theta. But since tangent theta equals sine theta over cos theta, shouldn't then tangent 2 theta equal sine 2 theta over cos 2 theta? It does. So essentially we're doing half the work to find the exact same answer. We're just being efficient about it. So sine 2 theta was negative 120 over 169. Cosine 2 theta, negative 119 over 169. Since we're dividing with fractions, we'll flip and multiply. We've got 169's top and bottom that can cancel out. We've got negatives top and bottom that can cancel out. So tangent 2 theta, 120 over 119.